So unless you are going for something.
All right, so welcome everyone, and I think it's 9 o'clock, 1 minute past, so I think we can start our course and begin. So just a reminder for those who just join my class either online or offline. Online students are only allowed for flexible students, all right? So everyone should come physically. I haven't prepared a sheet for signing simply because your names are still not stable. So I don't want to print many times. So it will be right here next week, right? But anyway, for those who cannot access anything or who just arrived to my class first time, we already begin our class a little bit. But if you cannot get all my resources, just go to chaklam.com, scroll down to natural language processing. Slides available, GitHub, all the code is here, and all the coding tutorials are there, right? For the YouTube, I and Gun already pre-recorded 20 more already. So we are still editing. It takes a lot of time. I realize that YouTuber is a very difficult job. But anyway, we will make sure that all our YouTubes is ready before your assignments, right? Yeah, and one more reminders. Make sure you all are in the Moodle. All right. So currently, these are the names of the students who are in the Moodle. So a lot of you guys are not yet here. So make sure you're here because your assignments will be, the first assignments will be assigned after my Wednesday class, all right? So that you have to submit every Thursday, right? Every Thursday. So if you click on your courses, you go to natural language processing and you scroll down, right? The Zoom record is already here for you. I may put this on the YouTube with the help of Gun, and then try to edit and make everything looks nice with subtitle, etc. But you can see that A1 is already here, right? Right, and I'm not sure. I think the PDF is not yet attached, right? Yeah, but here is the A1, and every Thursday you have to submit. All right, but for those who want to know, like, Chucky, what is A1? You can always go to the GitHub, right? And you can go to code, and I'm not sure. Okay, assignment and quiz right here, and you can click on assignment, and you can see all the PDF, right? So A1 to A7 is already prepared for you, but the only reason why we don't put it is because we don't have much time to do the Moodle thing, all right? But you can click on A1, and the feeling is very much like machine learning class. We prepared the things that you need to do, right? Read and understand the Word2Vec and Globe papers, modify blah, 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 right? Blah, blah, blah. And you also need to create a web application, right? So the way we design assignments, that we are aware that this is a 1 week assignment. So the scope is much smaller than your machine learning assignment. But Gun already tried, and he can finish within, like, let's say 5 hours, 5 to 6 hours, right? So for you guys, if you're confused, you probably take 12 hours 2 times, right? But that should be a good enough time for you to figure out the assignments. Yeah. Again, I have to emphasize that I'm a little bit more strict than usual on your assignments. Not because for me, I don't care about your gradings again, right? But because if I don't strict, you guys, the bad sides of you may talk to you that say, hey, just copy other, right? Which is not okay. and you will not learn anything. You guys don't learn anything when you're listening to me. When you listen to me, you learn 20%. Seriously. You can go to YouTube Stanford. You can search Stanford YouTube NLP. He teach like me, all right? I don't know who copy who, all right? But anyway, I probably copy him. He probably copy someone, and we all are the same materials. But anyway, you don't learn much. You only learn 20% from listening to my lectures, right? But the actual skills you learn from assignments. And we too work very hard to come up with assignments, right? So focus on your assignments. Yep. And when you come to my class, you just listen, chill. You just chill and relax and listen to me. But your real learning start when you actually code. Yep. All right. So that is all the announcement. Gan, anything I missed?
First, don't cast this one yet, but this one I not finalized. Each half for
Okay, so A1 to A7 is just tentative, right? You may want to add some more things, but yeah, the real one will be on the Moodle, right? Okay, great. Thank you very much. And now I think that we can start our lecture today, right? So we discuss about in NLP, how do we actually create meaning to words, right? And the idea is just create a vectors. Just a recap. What are the other same equivalent words for vectors? Word vectors. Any other similar terms? Word representations, right? That are also the same meaning. Word embeddings, right? So word embeddings, word representations, word vectors, they all mean the same. All right. So those are something that you need to take care of. And last time we talked about this slide. I know you won't understand this yet, and it takes a lot of time to come up with this, right? But I and Gan, we study so many papers, we become crazy, and so we try to make ourselves comfortable by making this slide for you all. Yep. So make sure you always take a look. We are right here, embeddings, Word2Vec, right? We are right here. So yep, word representations or word vectors. So the last time we talked about synonyms, one-hot vector embedding. So just some recap. What is the downside of using synonyms? Yeah, cannot do any operations like similarity, right? What else? Yeah, new words come in like kick-ass, wizards, ninja, freaking good, right? Those kind of words are not in the dictionary, so you always have to update, right? And also context, right? Synonym doesn't have context, right? So no. How about one-hot vector? So we can represent any words using a list of one-hot vector, like very long, right? If we have 50,000 words in our system, we have a 50,000 long vector, right? So what's the problem? Huh? A lot of zeros, right? A very long, right? And if you dot product, you cannot know whether they are the same. There's no operations you can do, right? So when the reason why I talk about this is you need to understand the reason behind everything here, and then you will have a very good foundations for your future career, right? And then now we have embedding, right? So we try to create. This is our what we want, right? We want to create a list of numbers. It does not need to be bound in any numbers. It can be negative, plus. This, by the way, if someone asks me what is this number, like, you don't know, okay? There's no way you can know. The computers, the neural network, learn this, backpropagate, right? They come up with this number. You will never know what are these numbers, and this is not your job to know what are these numbers, right? But what it does is that if you try to squeeze all these 9 numbers into some 2D space and plot them, they should be very near to similar words, right? This is what we want. This is exactly what we want. The next question is how long this should be, how big this should be. The common size is 50, 100, 300, right? No, I don't see anyone using more than like 1,000. No. So the next question you guys may have is which one is better, 50, 100, 300? If your system only use a very small, like very minimum words, like very little words, then the 50 should be fine. But usually I would say 300 is good bet, right? Because it covers a lot of words and it should work well. Right? So yeah, this is the idea that we want to. But how do we create this, right? How do we, first of all, how do we teach computers to know that think, expect, and say are similar, right? How do we teach? That is like the key. And before you say, how do we teach? You need to define what is similarities, right? Yeah, the way I teach you guys is I don't teach you only, I want to teach you, if you go back to 2013, how we think. And you can see that everything starts from definition. Definition, right? If you cannot define something, then you cannot measure that, then you cannot create any algorithms, right? So definition is very important. I'm not sure any one of you study with Professor Dung, but if Professor Dung is in your committee member, you always say, did you define this already? What is the definition of this? If you did not even define in the first slide, you will just reject it. And when I say define, definition means mathematically, right? Or concretely, not just a definition. I can say anything. I can say any bullshit. Similarity, it means when two words are similar. Similarity means when two words are used in the same context. This definition is useless. Do you understand? They are useless because you cannot do anything with it, right? But similarity in my sense is when they dot product, if they are same, they should be high. When they dot product, when they are not same, go low, right? This is a very, very good definition. All right. Now, once we define that similarity is dot product, then how do we say that these two things should be similar, right? We should define. Oh, I defined already. If this word is like to be close to some words, those words are similar. That is my definition. Maybe my definition is wrong, but at least that is what Word2Vec do, right? So for example, I don't know what banking should be similar. Oh, Chucky, it's so easy. You just define manually. Banking is similar to finance, insurance. I asked you how many words in English? 1 million words, right? Then you need to one by one, right? It's not the right way. So how do we know which word is similar to what? We use a philosophy approach. According to this philosopher, which we don't know, and his face is blocked, we say that if any words are near to this word within certain window size, then this word should be similar to that. Understand? Yeah. That means when they dot product together, they should be high. So for example, if I choose the window size of 2, this is the window size of 2, then what I want is that when I create a vector of turning, I randomly initialize anything. And when I dot product with banking, right, that should be a high probability, right? That should be high probability, right? And when I create a vector for into, when I dot product with banking, it should be high, right? Oh, how about problems? No, it does not need to be high, right? Because I specify the window size of 2, right? And you may ask, what is a window size Word2Vec use? Actually, in the paper, they have tried a lot, like 5, 10, 15, I'm not sure, right? That is your job for your assignments to read what are the window size they use, right? Yep. So those are the philosophy, right, about Word2Vec. Now let us look at the real equation, how they do this. Right. So this is the formal definition of the Word2Vec, right? So we got a huge corpus of text, right? So you can get any corpus of text from the Wikipedia, and you go through each position in the text, each position. All right. So let's say I have about something, problems turning into booking crisis, blah, 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 right? Which has a center word, C, right? So let's say I read each of the texts, right? But the moment I read, I'm into, I call this the center word at position T, right? I define this as the center word C. And then I define the context word O, right? So this guy are all the O, right? This guy are O1, O2, O3, O4, all right? Simply because I choose window size of 2, right? You may ask me, why don't I choose a window size of 3, 4, 5? Because I like this picture, okay? Make it small. Now, what we have to do is calculate the probability of O given C, all right? So how do we write this in mathematically, right? So the probability of O given C, all right? So that is how do we write. And for those who are not comfortable with probability, probability is something like, I'm gonna go to party, given that no rain, right? What is the probability? Maybe 0.9, right? Right? So that is the idea. Now, how do we, so we need to have some mechanisms to find this probability. I did not tell you how to do that yet, right? But we have to maximize this probability, right? Using gradient descent, right? Using gradient descent. So that is like the framework of Word2Vec. That's it, nothing else, right? So probability of word, last two word given the center word, the previous word given the center word, the next word given the center word, the next two word given the center word. So those that is the framework for Word2Vec. So by doing this, by going into each of the center word and try to maximize the probability, right? We're gonna have our vector is gonna slowly change, right? Slowly change. I did not teach you yet how to do this gradient descent yet. Okay, don't worry. We currently is in the high level yet. Right. The next slide is the actual equation, right? But the idea is once you try to maximize the probability, all these vectors change, start changing. Once I finish into, what do? I move to banking, right? I move to banking, and banking become the center word. And then these two become the O1, O2, O3, O4, okay? So in coding, how do we do? In coding is very, very simple. In Python code, for those who don't understand, like very abstract, in Python code, it's super easy. We just do like this. Into, comma, problem, into turning, into banking, into crisis. You will start to understand that for those who are very comfortable with PyTorch, we set this as X, right? And set this as Y, and just send and just use cross entropy loss. Actually, that's it, finish already. That's it, finish. But of course, when we send to cross entropy loss, we don't send the word into. We send the vector that is actually represented into, and we send all this vector and say that given this X, you should predict this Y, all right? And the probability should be high, right? So this is in the coding aspect. How do you think, right? So probably by talking from two aspects, mathematical and also coding, you better understand this framework, Word2Vec. Great. So now, once we are okay with this framework, the question is, how do we calculate this, right? How do we calculate this probability of outside words given center word? How do we calculate this? And of course, before I even talk about that, the Word2Vec objective function is simply because we want to maximize, right? We want to maximize. Then if we want to convert it into a loss function, J, so this is a loss function. J is very simple. We just put a minus. We just put a minus, right? And we apply a logarithm, right? And then change all this from product to summation, and that's it, right? So we want to make sure that all this probability, all this log probability sum up together. Put a minus here. We want to minimize this loss, right? Or for those who are not comfortable with this, another way to write is the likelihood that we want to maximize is 1 over t, basically the same, right? This is basically the same thing. Right? So you can write two ways. You can write the loss function, right? Or write, you want to minimize this or you want to maximize this, right? There are two ways to write and they are actually the same, right? Just a quick recap for those who study my machine learning class. What is theta here? What is after semicolon? What does it mean, theta? Here? What is the mathematical meaning of this theta? Well, this is what it is, right? This is the probability of this, right? Given this, and after the semicolon is parameterized by this. Parameterized by this. Okay, so that is the way you look at this equation, right? So that is the first question I have for you. Why do we need to put a logarithm in the front? Hey guys, you all study my machine learning course. Why do we need a logarithm? By the way, that's putting, huh?
Smaller words, a smaller number to be valuable, like you can see it.
Exactly, exactly. So if you just take the probability, you may get something like this, right? All right, you may get something like this, right? And computers, when you try to backpropagate or do any neural network, it causes a lot of problems, right? It causes a lot of problems, right? So if you take a log we just convert this to minus, like, I don't know, like minus 22, let's say, okay? Yep. And so logarithm make our numbers more stable. Then I want to ask you, does log change the meaning of the number? It does not change. The magnitude is still the same. If I have this and I have this log 2, I'm not sure, let's say log 3, right? Then you will get something like +1, I'm not sure, okay? So the relative magnitude will not change. This is called monotonic function. Monotonic function, increasing function, right? Which means that when you apply log, they don't change the meaning, right? That's why we need to apply log, right? And what is m here and minus m here? Window size. Okay, window size, right? So this is the window size, right? So if your window size is 2, then you want to take those 2 words, right? Except the middle word. You don't want to take the middle word because you don't want to take yourself given yourself, right? It doesn't make sense, right? So there's a J not equal to. Yep. 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 So Deepali asked a quick question. Minus mean. So let's say Chucky is flying on the balloon. And let's say this is J, right? Then this is J minus 1. This is J minus 2, right? And J minus 2 minus 1 is basically minus M. All right. And this one is J plus 1 and J plus 2, right? And that is the M. Okay. If M is 2, it will be like this. Now, quick question. What is T? Big T? Everything, right? So let's say your corpus is like you read a Wikipedia, and you have how many words? 10,000 words in one Wikipedia, right? Then you need to. So this is all the text, right? This is all the text. Then what do? You first start with this as J, then you move. This is the J. Then you move. This is the J. You move until this is the J. And then do, of course, left, right, right? And then do this is the J and left, right. Until where? Until the last word T. This is J. And then you sum up all the probability, it should be minimized. Understood? Yep. So this is the idea of T. So you need to move the window J. Every time you move, you do left, right. And then do everything. Yep. And then, of course, you want to minimize this, right? So that's why you put a minus, right? Good. And of course, the average. Yep. Okay. So now I think hopefully you guys understand this. When you listen to me, you probably understand like 50%. But when you look at my code, then you understand 100%, right? Yeah. But my code is it takes 1 hour to watch. So hopefully you guys don't give up yet. Okay. Great. So that is the objective function. Now, the question is, how do we calculate this? I never told you, right? How do we calculate this? All right. We say that we want to maximize this, right? Or if we put a loss function, we say we want to minimize the minus of this, right? Then how do we do, right? Firstly, use 2 vectors per word W, right? So what does it mean? It means that if I have something like flying, right? Then I have one vector for flying when this word is a center word. All right. And I also have the same vector when this guy is a context word, right? You may say, why not just one vector? I actually check a lot of implementations. A lot of the people use 2 vectors, but there's some people just use 1 vector, right? But I follow the Stanford way. They have 2 vectors. And then whenever they finish the whole training, they just average both at the end, right? When you train finish, for example, if flying as the center word is 1, 2, 3, right? And flying as the outside word is 2, 3, 4, right? Then the final vector of flying is 1 plus 2 divided by 2, and that is 1.5. 2 plus 3, 5. 5 divided by 2 is 2.5, and 7 is 3.5. So this is the final vector of flying, right? So that is the setup. But I never try whether you can use 1 vector. Maybe that could work, right? Maybe put it, I'm not sure. Yeah, I never tried. But the code I teach you in the YouTube, I use 2 vectors. right? Then you will not get lost. Then how do we form the probabilities? Well, the probability is very simple, right? The probability of the outside word given the center word, right, is simply taking the dot product of this. This is the main part. That's it. This is the main part. You want to take the outside word dot product with center word, right? That's it. That is the probability we want to maximize, right? Right. This is the probability we want to maximize, and the rest is not important. The rest. By the way, I just want to ask you, UO. Okay, U is the outside word vector, right? And V is the center word vector. Can I switch can I put VC here and UO here? Can I? Linear algebra. Hey, linear algebra. Answer is yes. Yes, right? Yeah. Okay, good. So the reason why I asked is so that when you code, you don't have to worry too much. Oh, Chucky say UO should be here, right? Then you guys confuse a little bit. And for those who always forget, you can go home and try to do this. 1, 2, 3, 2, 3, 4, right? Compare with 2, 3, 4, and 1, 2, 3, same results. Yeah. So it doesn't matter which order, right? Now, the first thing you may see is why we need to have a EXP. Huh? Exactly. Very good, right? So remember that EXP is basically making everything positive. All right. So it's a mechanism to make everything positive, and hence make it as a probability. Finished. That is like the mathematical behavior of this EXP, right? Now, why do we need to divide it by a normalization term? Yep. You may wonder, what is this? Well, we want to maximize this guy, right? But we also want to, if we dot product these two guys, maybe these two guys can be number like 5, 2, 3, right? Maybe, okay? I don't know, right? But you want to convert this to probability, right? Then you need to divide by all the vectors dot with this center word, right? Only the W change. You see, only the W change. The C constant. So every guy need to dot with this guy, and then sum them together, divide this guy. Then you will get a number that is within 1 to 0 and 1. Right? So this term, after you do, will be bounded in 0 and 1. All right. So that is idea. By the way, what is V here? Big V. Vocab. All right, vocab. So if you have 50,000 vocabs, I mean, vocabs means how many words you have in the system, right? Then if you have 50,000 words, you need to do 50,000 times here. All right. Then you dot, you will get a probability of that. Then once you get this probability, what do? You tell the computers you want to maximize this probability. How to maximize? Gradient descent, right? Gradient descent, the one that you learn in machine learning class. Right? Finished. Very, 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 very simple. For those who are like, I almost get it, but I don't see like super crystal clear, then you go to my YouTube, you watch my YouTube. How do I code one line by line? Then you should be okay. Yeah. Maybe today we have enough time to watch my video. Yeah, maybe, because we are going we only have 10 more slides actually. Okay, great. Anyone has any questions? Anyone? Okay, great. Now the training procedure. So we have everything now. We have all the setting up. Now how do we actually train this Word2Vec? So for each epoch, right? What is epoch? What is the meaning of epoch? With quick recap. Huh? Number of iterations. What is the difference between iteration and epoch? Every epoch, one epoch means you use all the training data, right? One epoch means you use all the training data, right? So this is the meaning of epoch. You sample mini batch of windows. Sample me. So how do I sample mini batch of windows? Well, this is what you can imagine, right? So I have a list of all the window. Like just now, I don't remember what I do. Flying, and Chucky is flying. Chucky, and then flying is, and then Chucky is flying on hits. Flying on, right? And flying and he's, right? This is the window of 2, right? And I will have so many, right? How many? So many, right? So if I have 50,000, if I have 10,000 words in my text, and the window size is 4, I don't do the math. I think you will have 40,000 window. I think maybe if you chop the beginning and the end, maybe a little less. Okay, so you can say if you have 10,000 words, each of the center word have a window of size of 2. You have 4 sample here, and then if you have 10,000, that would be 40,000 roughly. Okay, because in the beginning you don't have the previous 2 word, and the end you don't have the next 2 word, right? Then a little bit less. Yeah. So when I say mini batch, what do I mean? Maybe you just sample 128, right? Then you just take 128 of this 40,000, okay? Randomly, or again, if you guys will recall, how do we sample? You can do with replacement, exactly, and without replacement, right? Okay, quick, what is with replacement? Yes, so random with replacements mean I randomly pick, right? I don't care whether next time I pick something same, right? I just randomly pick, and then maybe it does not really exhaust the whole training data, right, in one epoch, right? But I just use the number of epoch same as without replacement, so that is the idea. But without replacements means that once you take this, then you take next, then you take next, right? Until you can never overlap, right? So that is a big idea. But of course, before you do this, you need to shuffle what? Shuffle this, right? If you don't shuffle, then it's not good. You should shuffle, yeah. Okay, great. So now, for each of the window, all right, so for each of the window, all right, calculate the probability of the context word given the center word, right? So how do we calculate? Well, it's very simple, right? So let me just erase this, right? So let's say my window is this guy, right? Let's say my window is this guy. Then how do I calculate the probability? It's super easy, right? I take the flying O, yeah, flying of O, right? This is the vector when it's an outside word, but actually this is center word and outside word, right? And we should do Chucky, yeah, Chucky as an outside word, which I don't know what is this, right? We dot product with flying as a center word, right? And then put an exp, all right? And then divided by all the guy, every guy O dot with flying C, right? And then sum them all together, right? Then you will have a number, right? You will have a number. Just quick question. How do we get this vector in the beginning? In the beginning, when we did not start training, how do we initialize this vector? Very simple, randomly. Just randomly initialize, right? We don't care whether it's randomly is what vector, but we randomly initialize. We hope that once it's randomly initialized, we try to maximize the probability. This vector will change, all right, eventually to be better. Yeah. Okay, great. So that is this step. So this step is not typical. Yep.
UWP.
You You mean below or top? Below. So below is so like this. In the below term is very simple. So below term is like this. You take all the vocabs, right? So you take all the vocabs of O itself. So it could be Chucky, right? And then just now the center word is flying, right? Flying C, right? Correct? And then what do? Plus. You do the next guy in the vocab. What are the other vocab you have in the whole system? So many, right? Then you do another vocab of O dot with flying C. Okay? And then do again all the words you have in the system, not only all the words, right? So this it can be, I'm not sure, like Harry, okay? And then the reason why I like Harry Potter is my kids like that, flying C. And then you plus, right? How many plus? Plus, I mean, I'm talking about the below term, right? And then what do is you sum them all up, okay? So that is the idea of this below term. Okay, good, great. Sorry.
Can be similar also or
So our friend here, Russia, asked when you initialize, how do you initialize? Do you initialize them to be very differently, or do you initialize them to be 0, 0, all 0, right? Usually we don't initialize them to all 0 because actually someone did and it can work, but it takes a lot of epoch because you have so many similar things. It makes a lot of time to move them differently. But if you initialize them very differently, so you can give a range to them that when you initialize, you start with minus 20 to 20, okay? Any number here can be minus 20, 20. Then you can do that. Then all the numbers will not be quite the same. But if you choose 0, 0, 0 or 0, then it takes a lot of time before they can be diverged, right? So usually you define a range to tell that when you initialize, please put all this number within minus 20 and 20. You may now have a question, then what is this magical number? I cannot tell you, right? But there's so many theory behind, like what are this magical number, right? Good. But the idea is like, you don't want them to be all 0. Otherwise, it's difficult to diverge. It takes more time to train. Okay, great. Any other questions? Yes. Okay, great. So we have a very good question from the gentleman here, and he asks, each word, does it have always the same vector? And the answer is yes, yes. So the flying will always has its own vector that doesn't change after you learn, right? It will there's only one vector for flying, right? And then you may say, okay, Chucky, then how do we actually deal with the context, right? Because we remember our example shit, right? Step on shit happened, right? Then actually there are 3 words of shit, right? How do we represent this? In fact, once you learn Word2Vec, you will find that that is actually still the problem. Okay, then we move forward to glow, to fast tag and bird, and finally the problem will be fixed. Okay, so that is a good question. Okay, any other question? Okay, great. Hey, great. So that is this step. Now, the next step is for each context word, calculate the probability, right? So I already talked about that, which is this is inside here, right? So we already do this, right? And now what do? Once you have all this probability, right? Then you calculate the loss, right? So this is like the prediction function. And once you do that, you calculate the loss, and the loss is nothing but the one we already talked about. Actually, I did not write it down, so why not I write it down here? So this is simply j theta equal to -1 over t sum, and minus log of all the probabilities of word of, actually, we don't need this probability of the outside words given the center word, right? So we just take all this, and this is the loss function. Yep. Again, I don't think we need a minus there because we already minus here. Again, because we want to maximize this, if we want to turn it into a loss function, we just put a minus, right? Then it becomes a negative function. Great. So that is the loss function. And next is calculate the gradient of the center word and the outside word. So you don't really need to do anything. You just back propagate, right? Making sure that so now you need to change the center word and the outside word, right? So you take the gradient of these true words in respect to the loss, right? And then this true word will change. So there you can see there are two gradients. Because you need to update the center word, you also need to update the outside word. Lastly, you sum all the gradients and loss within the window, and again, and then of course you sum all the windows, yeah, and then just continue do all the batches. Yep. And then finally, you update the center word vector and outside word vectors using this formula that you guys already very familiar, right? So this is this contains all the gradient, right? This actually all the whole term here. This contains all the gradients you learn, right? And which you sum up together and you multiply with alpha that can determine the direction. And then you want to go opposite of the direction, which is gradient descent algorithm, right? Great. So the training procedure is very, very straightforward, right? The next slide is a little bit difficult, and I don't want to even open the next slide yet, but I just want to say before that you don't need to really understand the next slide. The next slide is something that I prepare to teach you how do you calculate the gradient. But when you code, you don't need to do it because PyTorch automatically do it for you. You just say loss.backward, right? Remember in PyTorch, you just say loss.backward and it will just do it for you, right? So you don't need to worry. But for those who are coming from mathematics, you will feel something is lost in your soul. So that's why I prepare one more slide for you. You don't have to understand this. Understand? Yeah. So I'm gonna go to the next slide. By the way, anyone has any questions? Yep. Alpha, this one. So for example, this could be the vector of flying, right? The old fly, and this is the old flying vector. And how do you change this old flying vector? Well, you just take an alpha, which is the learning rate, and the learning rate could be 0.001, right? That is the typical thing we use. It could be 0.01, whatever, right? And then this is the gradient, right? This is the gradient, right? And the gradient, how do we learn the gradients? The gradient is when you back propagate, right? When you do differentiation, basically, right? And you will get this gradient, which is always the same shape as this vector, right? So that you can easily minus and etc. That is something we do, and yeah, simply that. Great. By the way, if for those of you who really want to know what is this, you go to my code, you follow line by line, you print line by line. I did not print line by line, okay? You print out, oh, Chucky, what did he talk about this? I don't understand. You stop when you calculate gradient, you stop, and then you just print. What does this gradient look like? You will finally understand what I talk about, right? You can pause my YouTube video anytime. All right. So now, okay. I will talk this. Okay, actually, I skipped that slide. That scary slide, but I think I should not. Okay, give me 1 second. Oh my goodness. Okay. I'm not good in Thai, but yep. Right. So this slide teaches how to actually calculate the gradient, and I create this just for those who really want to know how to calculate the gradient. Right. So remember that this is the loss function, right? This is the loss minus log y hat. For those who suddenly don't get that y is y hat. Y hat is basically probability of O given the center, right? Yeah. So y hat O. Okay. And we want to update. We want to find the gradient of this guy in respect to the center vector. I did not do for UO. Okay. I did not do for for UO. Okay. I did not do. All right. But it's the same procedure. Right. So you set up like this. Right. And this is simply this. All right. Very basically this guy is this guy. All right. And then because this is a log, division is basically minus, correct? Yep. And then because there's a minus outside, I think I put the minus here and then it becomes plus, right? Right. And then what did I change? What else did I check? Okay, I moved this differentiation term inside here, right? So we have two terms, okay? And then here is a logarithm and exp cancel. I got this term. All right. So you can see this logarithm and exp is very nice, right? And I did not do anything in this step yet. And then finally, for those who do a lot of calculus in your high school or whatever, or even in my machine learning class, you will realize that if you take the differentiate in respect to this, basically it's this guy, right? Right? You guys remember this trick, right? Yeah, you guys remember. So you already know why the answer is minus UO here, right? Where's my annotate guy? Yep. Right? And then differentiation of log, right, is 1 divided by, right? So you got this 1 divided by, but you still need to do some chain rule here, right? So you need to further chain inside here. And when you chain inside here, you'll get this guy together with this guy, right? So that is some kind of chain rule. And then finally, you just take this guy, put on top, right? Put a UX here. And then finally, that is almost done. And yep, this is the gradient. So this is the gradient that you guys need to code in your assignments, which I already code a lot. I finished coding already. I code this already for you, right? But this is the way you calculate the gradient, and this will be used. So this will be used here, right? Remember, theta of this VZ, right, equal to theta of this VZ minus alpha, and this term will be here. Okay, and this is how you update this vector. So that is the idea. Of course, this is just the gradient of one term. When this guy is set to the word, you have to do many epoch and many batch, and you will sum this gradient. You keep summing this gradient, and finally, once you sum all this gradient, you will put here, and then you will get the direction for this vector to change. Yeah. Great. Okay. I did not do for vector u, but probably you guys can see that it's not so difficult. But for those who feel like, Chucky, I don't understand anything about what you talk about, don't have to worry, because you guys are from the data science / computer science / computing area. You don't need to really be so strong in mathematics. But you need to be very strong in coding. Yeah, you are not strong in coding, you cannot do anything, like nothing. So you need to understand all my code, right, line by line. Yeah, but here not so much. Yeah. Okay, great. So how about I think it's at 10 o'clock. How about we take some break? All right, and then we come back. Yep. See you. Hello, everyone. I'm back, and now we continue from the Word2Vec gradients competition, right? But actually, we don't have much to. I think we only have. I checked already. We only have like 4 to 5 slides, right? So we can relax a little bit. Yep. I just want to let you guys know that there's a 2 version of Word2Vec, skipgram and cbout. I don't even need to show you this, but I mean all this text, but I can quickly tell you, right? The only difference is whether you predict the center word given the outside word, or you predict the outside word given the center word. That's it. Okay. But I don't know why they have 2 names very different, right? So if you have outside word to predict the center word is cbout. If you have center word to predict the outside word is skipgram, right? And you may say, in training, how does it different? There's no difference, because this is basically, this guy is the X and this guy is the Y. Here, this guy is the X, this guy is the Y. Right? So the very natural. So in cbout, this guy is the X and this guy is the Y. In skipgram, this guy is the X and this guy is the Y, right? But they are the same. It's just a list of tuple. Okay, it's still a tuple. Right? So there's nothing to worry about. You may wonder which one is better, right? And I can also quickly tell you that skipgram is better. Okay, skipgram is better. Reason why I have written here, and of course, you guys read the papers when you do the assignment anyway. Okay, great. So now we can go. So we have 2 skipgram this lecture, and so predict the outside word given the center word, right? And cbout, which is predict the center word from back of context word, right? So these 2 are basically just opposite of one another. But in terms of implementation, actually, in the original assignments, I already implement skipgram, right? I want you guys to implement cbout, but I deleted it because it's just so simple. Yeah, because it's just creating the path of training sample. So I deleted it. But anyway, so the cbout took hours to train, skipgram took 3 days, right? Because you can see that when you predict the outside word given the center word, you have more paths compared to predict the center word given the back of context word, right? So and also you may wonder, like, now which one is better? cbout is better for syntactic relationships, and skipgram is better in capturing semantic relationships. Syntactic is basically grammar, right? Grammar. It makes sense because cbout is basically predicting the center word based on all the context word, right? In that sense, it knows, like, before it should be what word, right? Next to it should be what word, right? Then the grammatical things will be better, right? But when you use a skipgram, given the center word, you need to predict what are the outside word, right? Then you probably better knowing the semantic relationships. What are usually things that I should worry about behind me and in front, right? So those are probably like the sense of understanding which one is learning what. But anyway, if you don't understand this, you can do 2 things. Read the papers. Another thing is just forget about everything I said and just remember that skipgram is better. All right. So that is something you can take away from this slide. So I actually written here and you can actually read this. But if you don't feel like you understand what I'm talking about, you read the papers. Yep. Okay, great. So this is something I want to talk about. And now these are the 2-3 slides I have left, and that's it for today. Negative sampling. And this idea is super nice, right? So you may find, for those who are coming from the mathematical background, you will feel that this guy, the lower term is not okay, correct? The lower term is not okay because you need to take V of this guy, right? So this guy is like, if you have 50,000 words, this will be done 50,000 times. So every time you calculate the probability, you take huge cost, right? To compute this, right? So the question is, how do we minimize, how do we not use this and still get the same thing, right? There's no problem with this, by the way. This is okay, but we don't want to do this guy. We don't want to do this guy, right? So how do we do, right? Now, we can do something called negative sampling. So what is the negative sampling? Well, what do? We want to, what do we want to do is maximize this probability, okay? Minus, right? The probability of some word that is not actually O, okay? Of this VC. Maybe we can call this a UK, okay? UK, London, right? So the UK, and put a minus here, right? We don't want this to be big, right? And so what is this UK? UK is basically any random terms that is actually not the outside word of VC, right? And then you call this guy negative samples, right? So this is probably the way to think, like, okay, can we do something like this? We want to maximize this term, but we also want to minimize this term, right? Because these two guys are not they are not the right pair, right? So we maximize this guy, we minimize this guy. So how many pair we need? How many of this K, right? Oh, when you ask how many, then there must be a summation sign here, right? Because you need to add up all these things, right? And of course, in this paper, this genius guy, he tried a lot, like 5, 10, 15, right? And I don't actually remember which one is better, but I think the idea is that too much is not good, too little is not good. It's a middle, follow the middle way, yeah, right? But of course, this is not the actual equation, right? Because we should make sure this is a proper probability, right? Because if you do EXP, this guy, if you do an EXP, this guy can be 200, right? And if you do this guy without this guy can be 300, right? Suddenly it's not probability anymore, right? Suddenly it's not probability anymore. So how do we convert to probability? Mathematicians need to think, oh, very simple. Just add a sigmoid in front. Remember sigmoid? So sigmoid function converts any number to the range of 0 and 1, right? And that is what sigmoid do, right? So you just put a sigmoid here and put a sigmoid. I'm not sure where, maybe here. I don't remember where they put it. So the idea is that, yeah. So this is the idea of negative sampling, right? So I'm informally actually introduced negative sampling. So now let us look at the real equation. Right. So here is the real equation. Okay, so here is the real equation. So we draw k random negative samples. All right. How many? Again, in the paper, they pick 5, 10, 15, and maybe I'm wrong. Maybe it's 20. I don't remember. You guys can read the paper, right? So what we can do? Well, if we take it as a j, then again we put a minus here. Okay. because we want to minimize this loss function. So minimizing or maximizing, we put a minus, right? So it's a little bit confusing, but I think you guys understand. If we want to maximize this, we don't have minus. If we want to minimize this, we have minus here. Okay, that makes sense, right? So this term is very similar, but what is different is we put a sigmoid in front, right, to convert the real pairs to a probability, and we take our log, right? But what we don't want to be high is this part, right? That is, this is some k negative sample that is not the real outside word of this C, right? And so that's why you put a minus here. Here there's no minus, there's a minus here, and then you put a log, and how many of them? K of them, right? And of course you minus again, right? So similar to minus here, this here is minus, but this minus will make sure that you don't want this. So it's like minimize of the minus. Yeah, it's a little bit confusing, but I think you understand. You probably understand that. Yeah, all right. So great. So this is the Word2Vec negative sampling that people actually use in the industry, right? You may be surprised, but in 2013 to like 2015, this guy is used a lot by a lot of people. One last thing I want to talk about is that negative sampling is a very, very important principle. And it's not only used here, it's used in so many neural networks like FaceNet, contrastive learning, basically anything, SimCSE, even SimCSE, this guy is like 2020. This guy is cited like 50,000 times, I think. It still uses negative sample, right? So understanding the concept of negative samples is very important. It's basically trying to, you create a vector, but you try to distance yourself from this guy to this guy, right? You make them far apart, right? So that is the idea of negative samples. But of course, if you don't understand this, go to my YouTube, watch the video, understand the code, and then you will eventually understand everything. And I think that's it. Right, great. So I think we finished our Word2Vec. Yay, the first lecture. Hopefully you guys feel more comfortable, right? After finishing the first lecture, you guys understand hopefully most of them. All right, so the models cannot understand words, so we need to assign ID, but ID cannot input into model. So the most easiest way to use one-hot encoding, but it's not good, right? So the conclusion is very bad, very, very bad. So now we have come up with a framework, Word2Vec. So what this framework tells us? First, what is similarities? Similarity is when you dot product, it should be high. Then how do you define similar words when they are nearby words? This is the philosophy. Do you think this philosophy is correct? Philosophy is never right or wrong, right? It's just some angle that if you believe this is correct, okay? So this is philosophy. Now, based on that, you come up, you have skipgram and cbound, and if you just skip my lecture, skipgram is better than cbound, right? And then, right, and blah, blah, blah. And lastly, if you take the Word2Vec, you will find that the lower term is very, very difficult. Then we introduce a negative sampling technique, which you can use for your code. All right, great. I have nothing else to do. And we're gonna see one another on Wednesday for Globe, right? Thank you very much and see you. Bye-bye.